starting of this course, I told you that three factors are very important in the VLSI design. One is nothing but the area, power, then delay. Right? Okay. In this video, we are going to concentrate on this factor, power. That is, we are going to find out the power consumption for all the three inverters what we have discussed. That is the CMOS inverter. Then we have discussed about the pseudo NMOS inverter and also the resistive load inverter. For all these three inverters, we'll be discussing on the power factor. So the power can be divided into two types: static power and dynamic power. Static power and dynamic power. We'll talk about dynamic power later, not now. Okay, that comes into picture when we have dynamic circuits. We don't have dynamic circuits now. All the circuits are static, and we know that. What do I mean by static circuits? The output is either pulled up or pulled down at any instant of time. It is not something between the pulling up and pull down stage. The output will either be pulled up or pulled down at any instant of time. If that is the case, then we call it as static power, right? Output will either be pulled up or pulled down. Done, right? Okay. So if that is the case, then let us try to analyze the static power of CMOS inverter first of all. So this is something interesting. Please listen carefully. So when we draw a CMOS inverter, like this, the input is coupled and output will be taken here, and it is grounded. This is the circuit of a CMOS inverter. So what is static power? When you know what is the meaning of static circuits, that is very clear. The output will be either pulled up or pulled down. But what is static power? When I talk about static power, whenever power depends on two factors, voltage and current, right? We can write power as a product of voltage and current. What is the current here? The current is nothing but the static current that flows between the VDD line and the ground line. So whatever be the current that is flowing between this VDD line and the ground line is called as the static current. Okay, and because of the static current, we will get a power called as static power. Okay, but one thing what we have to carefully note here is, only when there is a closed path from VDD to the ground, static current will flow, static power consumption will be there. So what I am trying to say here is, current needs a closed path to travel, that we know. Only when there is a path from VDD to the ground, there will be a static current and there will be a static power. If there is no path between this VDD and the ground, there will not be any static current, which will eventually lead to no static power consumption, right? So there should be a path between VDD and ground, then only the static current will flow. Okay, we have to just find out that whether the CMOS inverter provides any path between the VDD and the ground. That's it. So one thing what you have to note here is whether the CMOS inverter provides any path between the VDD and the ground. If it doesn't provide any path, then there will not be any static current, there will not be any static power. Okay, so how to find out that? We have only two possibilities. When the input is 1, what is the path? When the input is 0, what is the path? That's it. So first of all, let us try to analyze when the input is 1. So when the input is 1, logic 1, I mean, PMOS will be off, NMOS will be on, right? Output is again 0 because it will be pulled down, don't worry. When the NMOS is on, the output voltage will be pulled down. So when the input is 1, PMOS is off, because you know that when you apply positive voltage to the PMOS gate, it cannot attract positive charges, it won't form P channel, so it will be off when you apply 1. That is the trick I told you in the beginning of the classes. It will be off when you apply 1. So there is no path here. So when you transform this, the PMOS will be a open circuit and NMOS will be a closed circuit, right? So there is no path between VDD and ground. There is no closed path. As you can see, it is opened here. There is no path. So static power consumption will be 0 when input is equal to 1. So understand that when the input is equal to 1, the PMOS is off, so it forms an open circuit. So there is no current that can flow from VDD to the ground. So the static power consumption is 0 when you apply 1. That you have to understand. And for the one more possibility, that is, I'm sorry, for the other possibility, that is when the CMOS inverter, when we apply 0 to it, when you apply 0 to the CMOS inverter, okay, in this case what will happen here is the PMOS will be on but the NMOS is off, right? Because when you apply 0, NMOS will be off. So here you will get a closed circuit, but in the NMOS region you will get an equivalent open circuit. So there is no current can flow here. Current cannot flow here because of this open circuit. There is no path between VDD and the ground. There is no path between VDD and the ground. Current cannot flow. So static power consumption is 0. So static power consumption is 0 when the input is 0. So there are only two possibilities here, right? When the input it is 0 means current cannot flow. That is the static current cannot flow because there is no path between the VDD and the ground, and the static power also will be what? Will be 0 because there is no current, means static power equal to voltage into static current. So when you substitute 0 here, power will become 0. So when the input is 1, again the current cannot flow because PMOS will not be active, current cannot flow. So there is no path between VDD and ground, so current cannot flow. In that case also the static power consumption is 0. So static power consumption is equal to 0 for CMOS inverter. So for very beautiful property of a CMOS inverter, the static power consumption is ideally 0 for a CMOS inverter because there is no time that there is no instant that when both the transistors are active. See, when you want to make a current flow from VDD to the ground, when you want to consume the power, there should be a current flow from VDD to ground, right? That is only possible when both the transistors are on, but that is not the case. Both the transistors cannot be on unless in practical cases. Otherwise, in ideal cases, both the transistors cannot be on, right? So there is no static power consumption in CMOS inverter. This we have to understand because power is a very important factor in VLSI design, right? Thanks a lot.